All right, then capacity planning. So just a basic discussion of how you do a capacity planning. There are different factors that you need to be mindful of. So sizing design factors. So when you're designing a collaboration network, there are different factors to be considered, like cluster size. What will be the cluster size, whether you're going to use one subscriber or two subscribers or four or eight, keeping four as active and four backup, yeah, so on. Interaction between individual products, how the interaction between the individual products or end devices is going to happen, what will be the different protocols used, what will be the gateway protocols used, as we have different options for those as well. Server capabilities, optional capabilities and features, mix of all the types. System release, use of external applications, if any. Anticipated system growth, so you have to take care of, if in case of growth, how you have to upgrade and move the changes. Average and peak usage, and so on. So these are some factors which are the part of capacity planning or sizing factors. Then some security requirements. So it is very important in any network, whether it's enterprise or collaboration, wireless, everywhere, security is very important. So in collaboration network, there are some set of configuration and protocols which are used for securing the networks. Like on the end devices, make sure if you're using remote access, you should use SSH for security and not Telnet. So there are two of the remote access protocols that we can use, like Telnet and SSH. SSH is the secure protocol. Then on the access layer switches, to secure the ports to allow only the authorized MAC addresses to be configured to be able to send receive data, or authorized devices, use port security. Then on core and distribution layer, like routers and layer 3 switches, use access control list for packet filtering so that only the allowed traffic, for example, this access subnet, will be allowed to send traffic out or receive traffic based on the requirement set access control list on distribution and core. For authentication of the devices, use authentication servers like AAA, Radius, TechX, and so on. Firewalls should be used if you have a large enterprise, especially on the core when you are connected to outside networks. It is important to do the filtering and allow only the authorized traffic to cross the network. So firewall is required there. So these are some security requirements like SSH, port security, access control list, authentication services, authentication servers, and firewall. Then about dial plan. So in dial plan components, there are different factors again. There is endpoint addressing, there is digit manipulation, there is calling privilege, call coverage, call routing, and path selection. So first of all, endpoint addressing is required. Without that, the endpoints will not be able to communicate. They need the addressing to be configured. Then digit manipulation, if let's suppose you have some internal network structure, some network design, some DNs configured of, let's say, 4 digit, it will work within the network, that is fine. But when you are making calls to any PSTN or standard numbers, then you need to manipulate, you have to make it a standard number, or you have to strip down the call coming to a standard number back to the 4 digit DN within the organization. So all that digit manipulation has to be done. Calling privilege to allow certain calls for certain users. So privileges can be set. Call coverage, if let's suppose you are a customer care office and it's a pizza delivery customer care center, and you do not want to miss any calls from the customer. You want all the calls should be answered. So make sure call coverage should be implemented. So based on different algorithms, it makes sure that all the calls will be answered for the same DN, which is applied on n number of devices, not just one. But for customer uh, facing, it is just one number. Then call routing and path selection, of course, to make that call work and to reach the correct destination, you need to make sure your call routing and path selection is correctly defined and configured. Then some IP network protocols. So in collaboration networks, different IP protocols are required, like NTP, which is very important for time synchronization, DHCP for IP address assignment, DNS to resolve domain names or fully qualified domain names to IP, and IP to domain names, vice versa. TFTP for configuration, for configuring those devices, for registering those devices. CDP, LLDP for dis- for the VLAN information. These are the discovery protocols. CDP is the Cisco proprietary, whereas LLDP is the open standard discovery protocol to provide the VLAN information. SNMP can be used for management and monitoring. So here we can see an example of network time protocol, NTP, where our publisher is getting the time synchronized via the NTP server. It can be an external NTP clock or an internal NTP clock, which can be a router itself. Then this publisher is sharing this time synchronization with the subscribers and subscribers with the end devices. Then DHCP is used for IP allocation, which is very important in VoIP networks and voice over IP, because that is the base. Through IP only all the hosts and gateways and servers are communicating to each other. So IP is very important again. And for that, DHCP is required, especially in collaboration networks. Like on the IP phones, there is no way to manually assign an IP address. We require DHCP server to allocate IP addresses. So DHCP works to provide or to allocate IP addresses automatically, which saves time. You can do a configuration on the server itself, and then all the clients will just send a request to the server to obtain an IP from the DHCP, and the DHCP will release IP from its pool of IPs that they are configured by the administrator. So how does the DHCP works? DHCP works with a process called DORA process. DORA process stands for discover, offer, request, acknowledgement. Request and acknowledgement. All right, so here we can see a client sends a discover message. The discover message or the first message of DHCP is always sent by the client, which needs an IP address. It tries to search or look for the DHCP server in the network. So it will send a discover message as a broadcast because it doesn't know who the DHCP server is. So when the discover message is sent by the client, it is sent as a broadcast to all the devices in that network will receive it, but only the DHCP server will reply back as it belongs to the DHCP server. It is a DHCP discover message. Then it will reply back to the client with a DHCP offer saying that I have a pool of these IPs. So this is what I'm offering you. Then the client sends a request saying that, okay, please provide me an IP address. Again, it is a broadcast because it yet does not have an IP address. Then the DHCP server replies back with an acknowledgement saying, okay, I'm providing you this IP address, for example, 10.1.1.5/24. This was my first available IP from the pool, and this is what I'm assigning to you, and it makes sure that it is reserved for this client so that it does not assign it again to any other client. So this is the process of DHCP working. It works with four-step process called DORA process: discover, offer, request, and acknowledgement. Next is domain name system or DNS. Now, DNS is not a mandatory server. You can still work with IP configuration, but if you are using some domain names or fully qualified domain names, then it is mandatory to use DNS. Otherwise, the resolving of IP to domain names and domain names to IP will not be possible without DNS server. So there are some advantages of using just the IP address or using the domain names and hence using DNS. So if you're using just the IP addresses and you do not have a DNS server or a requirement for the DNS server, so these are some advantages with using IP addresses. You does not require a DNS server with IP addresses. It prevents the IP telephony network from failing when the DNS server is unavailable, of course. So if you have a requirement of DNS server, you have a DNS server to make all the requests. And if the DNS server fails, you will it affects the IP telephony network. Whereas in IP addresses, in the use of IP addresses, if you do not have a DNS server, it will not affect the telephony network. It decreases the amount of time required when a device attempts to contact the CUCM server. So, of course, because this time you do not have a DNS server, every time the request just goes directly, it takes less time compared to DNS, which in addition takes the time to resolve the source and destination. It simplifies troubleshooting just with the use of IP addresses. Some advantages of using DNS is it simplifies the management because of the use of names instead of numbers. So in some cases, maybe you are more uh, familiar with the names, or in the large network, you do not want to, make communication or requests based on IPs every time. You just want some descriptive names. So for simplified management, DNS can help. Easier IP address changes because of name-based IP paths in use of DNS. Server to IP phone NAT is possible in the use of DNS, and possibility to have redundant IP phone services. So these are some advantages of both using IP addresses and DNS. So as per the requirement, we can choose any type of structure. TFTP is Trivial File Transfer Protocol. Trivial File Transport Protocol, TFTP, is very important for providing configuration files or configuration for end devices. So there are some common TFTP issues that can occur. Like if the DHCP scope does not include option 150. Now, this is very important. One step before the TFTP is whenever the phones gets registered or when the booting process takes place, first it will go to to take the power. Once the power it has, then it will need the voice VLAN. Once it has a voice VLAN, it needs an IP address. But IP address is provided by the DHCP server. So you have to make sure that in the DHCP server configuration itself, the DHCP server should send the request forward for the next step to the TFTP. And for that, there is an option 150 required, which says that TFTP is enabled. And then you give a TFTP server IP also, which is the TFTP server, whatever your TFTP server is. It can be a router, which is your CME or CUCM, the IP address of that. Right? So option 150 must be enabled. If it is not enabled or not configured in the DHCP scope, it can be an issue that the devices are not able to get the configuration file. The TFTP service on the specified address is stopped or hung. So if the TFTP service has stopped due to any reason, then the devices will not get the configuration files. The option 150 in the DHCP server is enabled, it is configured like this, but the IP address is wrong. So that means the DHCP scope points to the wrong address. So these are some common issues that can occur. So while making the configuration or the setup for TFTP, these are some points to be careful with. Then CDP and LLDP, Cisco Discovery Protocol and LLDP protocols. These are the two discovery protocol that provides voice VLAN information. So CDP is Cisco Discovery Protocol. It's a Cisco proprietary protocol. LLDP-MED, on the other hand, is an open standard protocol. All right, so here we can see that we have a switch. On the switch, let's say we have a VLAN configured, VLAN 5, which is our voice VLAN. And this phone needs to get this voice VLAN information. So the protocol that will be required for this IP phone to receive this voice VLAN information will be either CDP or LLDP. So this is the two-way process, which it is showing here. So voice VLAN query via CDP or LLDP is sent to the switch. It gets a reply with voice VLAN, and that is how it knows about the voice VLAN. The next is LDAP. LDAP is Lightweight Directory Access Protocol, which can be used for user lookup, authentication, user provisioning, and authentication. So if you have a large environment, you do not want to add all the users and the end devices on the management server or on the call manager server itself, you can keep a separate server for adding the users, for authentication, provisioning of the users, making any changes to the user profiles, and so on using LDAP. And then integrate this LDAP server with the CUCM. So whatever users you are creating, whatever authentication needs to be done will be done via LDAP. Simple Network Management Protocol, SNMP, is a management protocol that provides management as well as monitoring. So to get the monitored device information or any information you want to monitor from the managed node, which is your CUCM, you can use SNMP for that. So different types of messages are exchanged between the device from where you want to monitor the server or managed node. So different types of messages are trap, inform, set, and get. So different types of components SNMP has is NMS, it has SNMP agent, and also it has MIB. So NMS is Network Management System. SNMP agent is the device or the managed node that needs to be monitored. MIB is the database management information base. This is the database where all these SNMP messages can be stored. You can set a timer to how long you want to store these messages, after how long it should be deleted automatically, or if you want to just keep them until manually deleted and so on. This is just a database of these SNMP messages. We have network management system from where you monitor the managed node, and SNMP agent is the managed node or monitored node. Okay, then some codecs we discussed like G711, G722, which gives you 64 kbps of bandwidth. We have G729, which is 8 kbps. We have some other ILBC and so on. So codecs can be used for different purposes and gives you benefits like bandwidth management, quality, endpoint support, network latency and reliability, transcoder avoidance. So consideration for codec selection is for different purposes like these. Then some IP phones, there are different series of IP phones. These are just some examples of different Cisco IP phones. We have 7800 series of devices or end devices, which are low cost IP phones, provides only audio, and the number of lines it provides varies from 1 to 16 depending on the model type. Then we have some 8800 series of IP phones, which comes with Cisco Intelligent Proximity. It is supported on 8851, 8861, 8845, and 8865. Then it gives you 720p video supported on 8845, 65, and 65 NR. It is supported for Wi-Fi also. These are the two series of 88,000 which supports Wi-Fi. Then some of the clients are like Cisco Jabber, which provides instant messaging, voicemail retrieval. It gives you soft phone as well as desk phone option. It provides presence features. Then there are some Cisco telepresence endpoints like Cisco telepresence SX series, MX series, which are already out of sale and end of support. Then we have telepresence DX. We have immersive experience 5000 series, which comes with a furniture from Cisco along with a controller pad here from where you can control the ongoing conferences. Then there is WebEx Room series devices, endpoint devices, which are used for meetings in the rooms or WebEx Room meetings. there are Cisco Expressway devices. There is Expressway E and Expressway C, which is used to make a communication from the mobile networks to the internal network or enterprise networks by bypassing the network for allowing the remote users. Otherwise, by default, if you have, let's say, some firewall blocking all the network, it will not allow the outside networks to be able to access the resources from the enterprise. So for some authentication and making open session between the remote users, it can be done via Expressway C and Expressway E, and there are a lot more that these Expressway devices can do, but that is a high level discussion and not part of this training. So just as an overview, so Expressway E is used for mobile and remote access. It is the devices that are supported are Cisco Jabber endpoints, Cisco Telepresence endpoints, and some Cisco IP phones. Then CUCM Express. So in this training in CLACCM, there will be a large focus on CUCM E, CUCM Express. So CUCM Express is a small scale solution, but we can do a lot more on that just by doing the configuration on the router itself and not having a physical hardware or a CUCM cluster. So what all a CUCM E can do is CUCME is Cisco Unified Communication Manager Express. It is a router-based solution. It can also give you some virtualized or GUI capabilities also. Virtual CME supports a maximum of 450 devices. That again depends on the series of the routers. Not all the routers will support 450 devices, but maximum up to 450. So this is the capability of CUCME. The registration and active calls are 113. So it can register and allow 113 active calls at a time or concurrent calls at a time. It provides call processing. To make the communication between the endpoints to the CME or CUCME, the protocols used are SIP or SCCP. But to make communication between the endpoints, the protocol is still RTP and RTCP. Now here is the Cisco IP phone registration process. So in the registration process, this is how the IP phones get registered. So let's say we have a Cisco IP phone and it needs to get registered and we have a CUCM server. There'll be different steps that will occur in the booting process, in the registration process. The first thing is the phone requires the power. So power can be power over Ethernet or through an external adapter also. So usually what we do is we get the power over Ethernet from the switch. So once the phone gets connected to the switch, it gets power over Ethernet from the switch. Next, it will get the CDP or LLDP response for voice VLAN. So first is this power, and then it requires the voice VLAN information via CDP or LLDP. Next, it needs an IP address. For IP address, it will contact the DHCP server. The DHCP server can be an external DHCP server or a separate DHCP server. It can be a router or it can be configured on the CUCM itself. So the four-step process will happen here that we discussed. Here it's just in short, they have just written request and reply, but we discussed that it is a four-step process in it in detail. There is discover, offer, request, acknowledgement. Once that is completed and is successful, the device will get an IP address from the DHCP server. Once the DHCP server has assigned IP, next it has to route it to the TFTP server. And for the TFTP server within the DHCP, there must be the option 150 and it should have an IP of TFTP to which it will then route. So then the IP phone, once it knows the information of the TFTP from the DHCP configuration, it will send a TFTP request to get the configuration files from the TFTP server, which is our CUCM only. And once it has the configuration files, it will send an acknowledgement and the registration is being completed. So this is the registration process. It gets power over Ethernet, gets voice VLAN information using CDP or LLDP, gets IP address information or IP address using DHCP. Then it gets the configuration files from the TFTP server and gets registered. So this is the detail of the booting process. The first step is power. It can be power over Ethernet or through a power cube or a power adapter. Next, it loads the locally stored image and it needs the voice VLAN. So for the voice VLAN, it sends a query using CDP or LLDP and gets a reply with the voice VLAN from the switch. Next, it needs the IP settings. In the IP settings, it requires IP address, subnet mask, default gateway, if there is any, DNS information, option 150. These are all the IP settings it requires, which it gets from the DHCP server. Once it has received all these information by getting the option 150 information, it goes next for the configuration from TFTP. It loads the it downloads the phone load. If local version doesn't match configuration file, the registration will happen in this order: primary, secondary, tertiary. You might have different, let's say, subscribers, and you want subscriber one to be the primary to register this phone. So this phone should be registered on the subscriber one or get information from subscriber one. And as we know, if you have multiple subscribers, there is a data replication between those subscribers. So in case the subscriber one goes down, you have to configure subscriber two as the secondary. It's your choice, whatever subscriber you want to mix, primary, secondary, tertiary, we can do that here. So this is for high availability. So this is how the registration will work. So if there is only one, then it will just register on one. If that fails, then it will not get registered at all. It will just be unregistered. If you have more than one subscribers, you can make them primary, secondary, or tertiary.